My name is Steve Bamshebi Samson. I'm the e-tutor for CSE 206 Urban Computer Interaction. We are in section 4, unit 3, user interface design programming tools. The learning outcome that is expected at the end of this is the student should be able to explain the various level of programming support tools, utilize tools for programming interaction objects, understanding the concept of the user interface management system. User interface design programming tools. The programming tools for the design of user interface gives implementation support for the level of service for programmers. These include the Windows systems that provide the core support for separate and simultaneous user system activities. They enable easy programming of the application and the control of dialogue between the system and the user. The interaction toolkit, for example, brings programming closer to the level of user's perception, while the user interface management system control the relationship between the presentation and functionalities. Advances in coding have elevated programming through hardware that specifically improve upon how human-computer interaction affect the programmer. Advances in coding have elevated programming through hardware that specifically improve upon the programmer's interaction technique. The layers of development tools, as earlier mentioned, also contribute to how human-computer interaction affects the programmer. These tools incorporate the Windows systems, the interaction toolkits, and the user interface management system as simplified in the following level of programming support tools. Windowing systems, device independent and multiple tasks. Paradigm for programming the applications, read evaluation loops, notification based. Then toolkits, programming interaction objects. Then UIM is conceptual architecture for separations, then technique for expressing dialogue. Element of windowing system, device independent. Programming the abstract terminal device drivers using the image model for output and input is device independent. Also, device independent is the creation of the image model for output and the inputs partially. These image models are the pieces, the PostScript and Macintosh operation system and Netscape, the graphical kernel system, and the programmer hierarchical interface to graphic. Resource sharing. Another element of the windowing system is resource sharing. This is the art of achieving simultaneity of users' tasks. Resource sharing enables the users of the Windows system to support independent process by isolation of individual applications. Element of windowing, role of windowing. So you can see application program. Those are the top layer. Then windowing, multiple application control. Then device independent. Then that goes to the interface, mouse, window, then keyboard. As shown in the diagram above, the windowing system comprises of multiple application control and device independent control enable the interface between the application programmer and the user. Then the architecture of windowing. The architecture of windowing system are analyzed through three possible software architectures. If we all assume device driver is separate and know how they differ, how the multiple application management is implemented, the three possible software architecture are in the following. When each application manages all processes, here everyone worry about synchronization and reduces portability of applications. Two, when management rules within the kernel of operating system ensure that applications are tied to operating system. And three, when the management rule as separate application ensure maximum portability. The client-server architecture is illustrated. So you can see the client-server application, then the abstract terminal, then we have resource management and device driver, then we have the interface that the user interact with directly. Then X window architecture. The X window architecture comprises the pixel image model with some pointing mechanism and the X protocol that define the server-client communication. The architecture also contains a separate window management client that enforces policies for input and output. Policies on how to change input focus how the tied windows compare with overlapping windows and policies on inter-client data transfer. See the pictorial illustration below. You can see the image also to the X server, the device driver, then the window management client, the applications, and we have the interface for the user. Then we also have the typical program model of application program, where we have the device, the server, then the client applications, read input, and so this is how it flows. And this is typical read evaluation loop provided by the repeat. So you can see. Then this is also how it is, how program all these values to generate results. You can see the application state registered, slots, start, registered, callback, with notify them, callback, notify them, processing. Then we have the notifier at the other hand of the read inputs. Send application appropriate callback. So using toolkits, user interface toolkits. User interface toolkits are probably the most widely used tool nowadays to implement applications. All three major platforms, Unix, Linux, Mac, and Windows, comes with at least one standard user interface toolkit. Toolkits are interaction objects with input and output intrinsically linked. They enable programming with interaction techniques using and gadgets. They promote consistencies and generalization through widgets, similar look and feel. A widget is a software object that has three facets that closely match the MVC model: a presentation, a behavioral, and application interface. A sample illustration of widget is provided below. Button. Move, press, release, move. The presentation defines the graphical aspect of widget. The overall presentation of an interface is created by assembling widgets into a tree. Widgets such as buttons are the level of trees. Composite widgets constitute the nodes of the tree and control the layout of their children. The behaviors of a widget define the interaction method it supports. A button can be pressed, a scroll bar can be scrolled, and a text field can be edited. The application interface defines how a widget communicates the result of the user interaction to the rest of the application. It is usually based on notification mechanism. One limitation of widgets is that their behaviors are limited to the widget itself. Interaction techniques that involve multiple widgets, such as drag and drop, cannot be supported by the widget behaviors alone and require separate support in the user interface to prototypes and widgets. In general, prototyping new interaction techniques require either implementing them within the new widget classes, which is not always possible, or not using a toolkit at all. Implementing a new widget class is typically more complicated than implementing the new technique outside the toolkit. For example, with a graphical library and a rarely justified for prototyping, many toolkits provide a blank widget, such as the canvas in TK or JFrame in Java Swing, which can be used by the application to implement its own presentation and behavior. This is usually a good alternative to implementing a new widget class, even for production code. A number of toolkits have also shifted away from the widget model to address other aspects of user interaction. For example, GroupKit was designed for groupware, JAS for zoomable interface, the visualization and info piece, Toolkit for visualization, Inventor for 3D graphic, and Metis for window management. Creating an application or prototype with a UI toolkit requires solid knowledge of toolkit and experience with programming interactive application. In order to control the complexity of the interrelations between independent pieces of code, creation of widgets, callback, global variable, etc., it is important to use well-known design patterns. Otherwise, this could quickly become unmanageable, and in the case of prototype unsuitable to design model, toolkits are amenable to object-oriented programming using Java interface that include the abstract windowing toolkit, a Java toolkit, and some Java classes for buttons and menu, etc. Some Java interfaces are notification based such as AWT 1.0, which needs to subclass basic widget, and AWT 1.1 and beyond with callback object. 2. Toolkits built on top of AWT with higher level features that also use the MVC architecture. The user interface management system add another level above toolkit because toolkit may be too difficult for non-programmer. Concern of user interface management system include the conceptual architecture, the implementation techniques, and the support infrastructure. The UIMS as a conceptual architecture. The conceptual architecture is viewed as a separation between application semantics and presentation. This improves portability, which run on different systems. Reusability, having components reused, thereby cutting costs. Multiple interfaces that access same functionality, and customizability here. The system is customized to suit designer and users. The user interface management system. Tradition of interface layers and logical component comprises. Using toolkits: linguistic, lexical, syntactic, semantic. So then ArchLink. This scheme model, it is conceptual and implementation. Then same concept arose as a result of implementation experience with conceptual approach as principal contribution. The concepts are part of the normal user interface language. User presentation, dialogue, functionality, application, then switch. The above depicts different kind of feedback. For example, the movement of the mouse carried out at the presentation interface is known as lexical feedback. The menu highlighted as a dialog control is known as syntactic feedback, while the function carried out at the application interface, such as sum of number changing, is regarded as semantic feedback. Because the semantic feedback is often slower, programmers prefer to use the rapid lexical or the synthetic feedback. The lower bus representing the bypass switch is needed for implementation. The switch enables a direct communication between application and presentation, though regulated by a dialog control. It is also provided a rapid semantic feedback. The ARCHI snake model characteristic. This model contains layers to distinguish the lexical and physical like a snake spring. Different layers may be thicker, that is more important, in different systems or in different components. So we have functional core, functional adapter, dialogue, lexical, and physical. Monolithic offers us components seen as big component and is often easier to use smaller one specialized if using object-oriented toolkit. Small talk, use the model view code row. Model indicates the internal logical state of components. View show how it render on the screen. Then control process user inputs. If you understand that concept, it will be easier for you to interpret the model view controller. Model view controller. I just explained it in the last in the previous slide. So model view issues, the issues that arise between them. So is likely pipeline model. Using the pictorial illustrated above, the input is transmitted to the controller, which is coming from the keyboard. Then the controller processes user input and connects it with the model. Since the model represents the internal, the logical state of the component, a manipulation is carried out, and through the view model, the result of the manipulation is what comes to the screen. That is output. In graphical interface, input only has meaning in relation to output. E.g., a mouse click, there is the need to know what was clicked, and controller has to decide what to do with the click using the internal logical state of the component through the model. The view display how it is rendered on the screen. However, in practice, the controller directs talk to the view. Or this process is still similar to all the process that you know about how a simple system operates. It is what you input that will be processed by internal model, and then it can only be viewed through what the model supplied to the view. Then the user will now be able to view through the screen. The presentation, abstraction, and control pack. model presentation is still in line with what we've just explained, but it's just in different terms. So where we have abstraction, which represents the model, then where we have presentation, which represents the view, then control still remain the same. The park model is closer to scheme model in principle because the term presentation describes input and output are managed. The abstraction describes the logical state of the component, while the control represents the state of mediation between the presentation and abstraction. The park model manages the hierarchy and multiple view through the control part of park communication. The abstraction through the park model is direct. The MVC model is used more in practice, as can be found in the use of Java Swing. The implementation of user interface management system take the following form. The implementation of the techniques for dialog controller through the use of the menu network, state transition diagram, grammar notations, event languages, declarative languages, constraints, graphical specifications. So, in conclusion, programming tools for design of a user interface enable easy programming of the application and control of dialogue between the system and the user. Level of programming, in summary, level of programming support tool comprises windowing system that are device independent with multiple tasks. The paradigm for programming the applications with read evaluation loop that is notification based. Toolkit containing programming interaction object and the user interface management system made up of conceptual architecture for separation together with techniques for expressing the dialogue. The layers of programming development tools contribute to how human-computer interaction affects the program. With this, we have come to the end of Unit 3 of Section 4 of this CSC 206.